So we're going to go through a process of building up a server. And remember, it's just about a request coming in and responding to that request. And we're going to start by doing a TCP server, and then we're going to come down here and understand HTTP servers. And this one is just like advanced, kind of fun to look at. But these are the ones that are going to teach us what we need to know, and then these are just kind of like cool little examples of them. So let's just look at them. And I've put instructions into each of these folders about how to use this. So you're going to need Telnet, because Telnet is a way that you can make a call on TCP. It's a program. And it comes installed on a Mac, but you can install it on Windows. And so to run this program, right, and I'll just run it first before we look at it. I'm just going to go into that directory, change documents, come up a ways, and change into 015, 01, listen. I don't know if listen does anything. We'll have to look at the code first. All right, so here's the code. So in the standard library, godoc.org, there's the net package, just net. And unless you've taken a networking class, which I have not, I'm no comp sci person. Somehow or another, I ended up teaching programming classes, and I studied economics and business. But I kind of think it's fun. Unless you're a networking person, a lot of stuff's just going to be like, I don't know what the hell all that stuff does. However, I do know what listen does. So on my network, right, from the net package, I'm going to listen. And I'm going to listen on TCP. Okay, cool. And TCP is just transmission control protocol, right? And great, that's one of those layers in the networking model, and it's below HTTP, and that's the layer I'm listening on. Fantastic, right? Listen, TCP, port 8080, and when I do that, I know enough about Go now as I can look at listen, and okay, these are both strings, net and listening address, and so I've given them strings, TCP 8080, and it returns a listener and an error. All right, that's cool. A listener and an error. So I'm assigning it to LI. Okay, and I could go look at the standard library. I know enough about the standard library now that when I have when I get back a type, I could look to see in index, does that type have any methods associated with it? All right, so here's type listener, and no, I don't see any. So it's just kind of interesting. There's TCP listen. That's kind of interesting. It's got some stuff attached to it. And then Unix listener, interesting. But the one I've got here, right, just gives me back this listener. It's a listener interface. The listener interface, cool. All right, its type has accept, close, and address returns the listener's network address. That's interesting. So anything that has this, an interface defines functionality. Any type that has these three methods attached to it is a listener. Okay. All right. So don't have to understand. Like, programming is always operating on the threshold of your understanding. You're always going to come up against, like, I have no idea, how my CPU is actually, like, processing, right? Like, there's assembly, and then there's binary, there's fetch, decode, execute, there are registers. There is the set thing that it does, and the wires, the bus coming in and out of the CPU. There's the read wire and the data wire, or the address wire and the data wire. It's like, okay, and I don't know how the hell it works. Like, I know a lot of details about it. I don't know how the hell it works. So it's always operating on the edge of what you understand. So I get back my listener. I defer the close, since that's one of the things you do. You don't want to just leave your listener open. I create a forever loop for, just keep looping forever, right? There's no conditions there for it to stop. And I accept any connections that come in. All right, so what happens when you do accept? There's accept, and accept returns a connection and an error. So I have my connection, and so with my connection, and just out of curiosity, what happens when I click connection? A connection is another interface. And anything that has these methods is a connection. Well, that tells me those methods are available. And those two particular methods right here, read The read method and the write method, these are from, I'm just wondering why it doesn't take me there. Main.go, okay. Those are from godoc.org/IO. And there's type reader, and there's type writer. And these are also interfaces. And so this is kind of how we learn to pass things around and what can work with what. You've been given all these different little Lego components. And like when you play with Legos, like certain pieces only fit together with certain pieces. Right? And so this is how you get like this piece. Can I fit this piece with that piece? All right, well, this needs a reader. Okay, cool. A reader is anything that has this method attached to it. Any type that has this method attached to it. A writer is any type that has this method attached to it. Well, interestingly, connection has a read and write. It has those two methods attached to it, so it's both a reader and a writer. And so anything that wants a reader or writer, I could pass a connection into it. Because it has that function, that method. So it's a reader and it's a writer. So my response is going to want something that can write. Cool, I could pass this to my response. Or, you know, anything that wanted to read from it, I could pass this to it. You could read and write from a connection. Makes sense, doesn't it? I could read from that connection. Something's coming in. Now I could write back to that connection. I want to send something back. So I accept my listen, right? And I get a connection. And now write string, what does write string want? Write string wants a writer. Sweet, my connection's a writer. I'm going to write back to my connection. So I write back to my connection. And then format sprint. What am I writing back? What does write string take? Write string takes a writer and a string. Returns number of ints. Or an int, it returns bytes written and an error. All right, so I pass in this string, and then I close my connection. And then I go back to listening for anything else to accept. And so when I run this, 01, that should actually run. Go run main.go. It's running. I can't go to the HTTP, right? I need to go to Telnet. Let's just look at the instructions. On Mac, start main, telnet localhost, and this needs to be 8080. So I'm on another terminal. I started a new window, and I'm going to do telnet localhost 8080. And connect to the localhost from server, hello class. Right? That's what I wanted it to print out. And then connection closed. I could call back in. And so I called in from Telnet. The server is listening on that port. And it accepts it, gives me the connection, and it writes back to that connection this string, and then it closes. It's just interesting. And if you're getting that part of like, oh, I kind of see how those interfaces allow things to allow some modularity where different things can plug in different places. Right? IO write string wants something it could write to. It takes a writer. Well, hell, this thing implements the writer interface, so I could stick it in there. Then we have dial. So here we have connection net dial. And this lets me dial localhost 8080, right? And dial, net dial. So I'm kind of interested to find this stuff in the library. So we were doing the standard library. We were doing listen, which is net listen. Listen IP, listener, listen packet, listen TCP, listen multicast, listen Unix, listener examples. It's just it, man. Like, where is just net listen? Like, it's used right there. And so let's come back over to our code here, open up this one, and look for net listen. Takes us to func listen with this signature, so I'm just going to copy that and come over here and command find. There it is. Listen. Type listener, listen, net gives me back a listener. Kind of interesting. So where's dial? Dial. There's one there. Dial P. Dialer. Type dialer. So there's a listener, there's a dialer. Dial, network, and this gives me back a connection and an error. All right, so we had listener, dialer. If you knew all this stuff, I imagine you could look at the standard library and just be like, oh, cool, that's what I need. All right, so now I'm in this one, and the instructions are, all right, run the file in O1, then run the main Go file in this folder. So let's see what happens. So I'm in O1, so I'm going to do the go run main. And I'm going to go into a new tab, and I have to go over here, shell new tab. I'll do new window. Different color, funny. And I have to change all the way in there. Documents, go workspace, source, GitHub, goes to 11, golang web dev, and then change into 015, and it's 02, and go run main. From server, hello class. So I dialed in to that server using dial. Right? Just ran that program. Instead of having to do it like this, like I did before, telnet local host 8080, I could do it that way, right? Or I could run a program to dial in on its own for me. Listen, TCP 8080. As the listen one, here's the dial. Det dial here, that connection. All right, so I got my connection, deferred the close, IOUtil read all connection, right? So IOUtil read all, what's read all do? So from IOUtil, read all takes a reader, returns a slice of bytes and an error. And so here's the byte slice, and I threw the error away, and I took the byte slice and I turned it into a string. What's a byte slice? So the interesting thing about that, read all wants a reader. Oh, cool. I could read from my connection. Why can I read from my connection? Because netdial gives me a connection which has this method. Anything that has that method implements the reader interface. If it implements the reader interface, it's a reader. So wherever something is asking for a reader from package IO, cool, I could pass in a reader because it has that method. This is kind of interesting. I give byte slice back, and then I just convert it to a string. So I put together this little file the other day and then put it on Twitter. Because recently I've become a Twitter junkie. And I'm looking for that's it? It must be farther down. How could that be it? I thought I had more than that a minute ago. Now I went down in numbers. Oh, hell, screw it. I'll just recreate it. Okay. So I'm going to do string colon equals. And just so you don't think string is some special, I'm going to do s is equal to that. Print s. Format.println. Slice a byte. S. So this is not assertion, it's conversion. What we saw earlier was assertion. This is conversion. So that gave me all of, like, hello, hello. We'll just do it with hello. Just a little bit shorter. Or we'll stick with hell. Low. Right? So those byte slices, right? This is a slice of bytes. A byte is eight bits. And 72, talked about coding schemes a couple of weeks back. 72 is capital H. Right? So that's how we get capital H. Capital H is 72. Lowercase e is 101. So we could go from a string to a slice of bytes, and we could go from, whoops. We could go from a slice of bytes back to a string. Okay, string, conversion to a slice of bytes, conversion to a string. So byte slice and a string, sometimes you get byte slice back, sometimes you get a string. And it doesn't necessarily have to be text, right? So it could just be bytes, zeros and ones. Just for fun, you could do this. Because it's a slice, so I could range over it and print out each one individually. Or I could do this. Slice a byte, my string. And then if it's a slice, I could say, just give me what's in position 3. Or give me what's in position 2. .108 is in position 2. And then you know what? Make that a string. L, H-E-L, position 2. 0, 1, 2, right? I could also do slicing, but we haven't talked about slicing, but maybe now's a good time. So slicing is, I have a slice of byte for that string, and I'm going to slice it, and there's an operator, colon, and I can say everything up to but not including 2. So it's going to be he. Didn't like that. I need this. Gave me those 2, right? But if I string it, conversion, he. So that's slicing this deal right there. Or I could just do from like position 2, 0, 1, 2, 3, that'll be the last L, through the end. And that's going to give me LO. Hello. Kind of nuts, huh? I'll put that in for you. I've closed our document. That's brilliant. Blackboard. So this would be a string slice of byte. You can watch this online, get to that document right there. Done with that. So we're learning about this, right? We got a byte slice back, so I just converted it to a string. That's what readall gave me. We're learning about this, Nina. Got a byte slice back, so I just converted it to a string. That's what that entire little show was. So we listen and we dial, right? Response request. And this is just like the edge of our understanding of where we're going to go with networking, seeing as how most of us in here haven't had networking class, including myself. But it kind of makes sense from a logical standpoint. All right, sweet. There's a net listen. There's a net. And once we get a listener, we can accept a connection, you know, and we could write back to that connection. We're understanding the interfaces, things that implement have these methods. If it's a writer, if you have this particular method, you could go wherever writers ask for. But you listen for a request and then you respond. And so you could do things like this echo server, you know, where we listen and then we do our eternal loop and we accept the connection, right? And then inside there we do another eternal loop and byte slice, make a slice of bytes, 1024. We read that byte slice, then we write back to the connection and then close it. Listen, close, accept. Let me see if version 4 looks easier to read. Listen, accept. I like this one better. So then we just copy what comes in to what goes out. So copy takes a reader and a writer. So we read from what's coming in, and then we write going out. So this is like an echo server. And there's a couple of different iterations of it. Just see if any of them, buff.io, new scanner, any of them would be simpler to accept, copy. This is the easiest one. I like that one. So listen, accept, right? And then copy from what's coming in to what's going out. And then close the connection. So I'm going to run that one. And we close this. Control C, close that. And I'm going to go up a level and change into O3, echo, and VO3. Go run main. And then do another window and telnet local host 8080. Hello. Echo. So what I send in comes right back out. I don't know why I'm control C'ing. That should, I need to close that? Terminate. Control C. There we go. So then there's a Redis clone, which gets pretty fun. And I'll show you that, version 5. We'll see it first, and then we'll change directories. And that's going to be, where am I? 015, change into 04, version 05, go run main. And just enter anything. Oh, I got a telnet in, Command T. Telnet, local host 8080, and something. What's it doing? Instructions. The telnet localhost 9000, it says. I think it's 8080. I actually need to do a control find 9000. Oops, and change it to 8080 all over. Find Found occurrences 92. Where's my replace? Replace. Oh, it's still thinking. It's a big project. I'm breaking my computer. All files. Oh, whoa, that's crazy. It's in, that's nuts. Cancel. I'll deal with that later. All right, so let's see if I could actually set something. Set, fave, pop. Invalid command set. Set, fave, pop. Get, fave, pop. Del, fave. Get, fave. Nothing. Set. Set. Nina. Tired. Get. Nina. Tired. So.
Can you tell?
Huh?
I can tell I'm tired.
You and me both. So you can look at the code on that. And, you know, you got your listen, you have your accept, and then you pass your connection to handle. And handle takes a connection, net, this variable of this type from package net, you know, type connect, from package net type connection. Then defer the close. And buff.io, new scanner, scan the connection, get a scanner. Scanners are kind of somewhat still new to me since I've only been coding 3 years, but you could scan something and then you could run. So if we look at what a scanner does, scanner returns a new scanner to read from R. Well, it's a reader, anything you can read from, like a connection. Split function defaults to scan lines. So there's a split function and it'll scan lines. So if we go look at buff.io, package buff.io, and we're just getting a cursory understanding of this stuff, and we look for type scanner. If we get a new scanner, so we do new scanner, we get a pointer to a scanner, and then we have these things like scan available, right? Or, you know, and so we could read, you know, like new scanner gives you a pointer, it returns a new scanner to read from R. And then we have like scan, advance the scanner to the next token, which will then be available through the bytes or text method. Returns false when the scan stops. All right, so it advances to the next token. So we get a scanner, and then scan takes us to the next token, right? And so it'll be like this one, this one, this one. And then what's scanner text do? And text returns the most recent token generated by a call to scan as a newly allocated string holding its bytes. Okay, so we do scanner text. So this scans everything and breaks it into lines, and then we do a loop over that, and it gives us each line, and then we do scanner text and gives us the text on that line. And I don't know, and then we could take that line and strings fields. What's that do? Field splits the string S around each instance of one or more consecutive white space characters and gives us back a slice of string. So it gives us all of the words, right? And so that it's a slice. And if that's less than 2 in length, then we're just going to go back to the next part of the loop. And then we have, hey, switch on FS0, the first word I've put in, and get set del, right? Runs the different code for each of those. Kind of interesting. But you know, it's not light. So that's the TCP stuff. And then we slip into HTTP. And for HTTP, it's pretty similar. And we'll look at that in the next video.